Good morning, students. Today what I am discussing is dispersion. Dispersion, this part is not there for PU theory and also for the CET. For CET purpose not required, but you need to know, even CET students should know only the concept of it. No need to remember the formulas. But for the NEET and JEE, formulas are also required. What is dispersion? Is splitting of the composite light, means mixing of the color with different colors mixed up you have taken. Mixing of the composite light, if you send it to the prism, prism may not be triangular shape. Generally we discuss about the triangular cross sections. When passed through the prism, it splits, that wavelengths, depending on the wavelengths, it splits into different directions. They are deviated by different amounts. And deviation depends on the refractive index of this material with respect to surrounding medium. This is N2, this is N1. So N2 by N1 is the relation for the refractive index relation we will take, and more refractive index difference you will take, more the light rays will be deviated. Instead of going straight, they will be bending and going in other directions. This is N1, generally we take it as air, N2 is N we take. Angle of the prism is called as the refracting angle between the two surfaces where the refraction is taking place. If you take the white light, which is a composite light, which is a mixture of the 7 colors, passing through the prism splits into different colors depending on the wavelength. What is the relation for this wavelength variation is nothing but the refractive index is equals to 1a plus b by lambda square plus and so on. Lambda increases means n value decreases. Higher terms generally we neglect. As lambda increases, n value decreases. And a and b are the constants called as the slopes of the from the graphs related experimental related problem. That one you don't know. Just know that if the refractive index if the wavelength n increases, refractive index decreases. So if you take the VIBGR, if you take in the VIBGR spectrum, visible light spectrum, violet red, the wavelength starts visible light from violet 4000 angstrom units or 400 nanometers to red, that is 7500 angstrom units, approximately sometimes taken as 750 nanometers, or can be written as 8000 angstrom units also, depending on the problem they will give you approximate values for this. This is 4000 we take, but here approximation we take. And if you take the VIBGR's colors, the eye is more sensitive towards the yellowish green light, which is the average of the violet red lights wavelengths. And if you take the blue and red, the average will be yellow. This is 550 nanometers, this is 500 nanometers. So white light refractive index, if you take 1.5, we talk for the glass, for water 4/3 1.33, that is for the average of these values. Average of these values is for 500 nanometers or 5000 angstroms. That is in the yellowish green light. In the new leaves of the trees will be related this yellowish green light, which is pleasant to see for the eyes. But if you take blue, red, generally we take for the problems blue and red only. Why? Because when you mix a violet, indica and blue, our eye is sensitive towards yellowish green light. Therefore, if you mix a violet and blue, our brain senses it as a blue only. Even indigo mixed with blue also, mixing colors indicates as a blue only. Therefore, we take the generally for problems purposes, blue and red we take. Blue and red average value of the refractive index or average valence related to yellow light we take it. So here refractive index of the average refractive index, the blue and red means yellow, and violet and red means yellowish green light. Yellowish green light directly number we do not remember. Generally we take is 500 to 500 nanometers as the white light wavelength. So wavelength increases towards red and frequency decreases in this direction of red and increases towards violet. Relation is C equal to F lambda. C is constant here for all these colors, which is same for all colors in the vacuum, which is 3 × 10⁵ meter per second in vacuum only place. But if different metal means depending on the refractive index, speed changes. We are talking here only in particular medium, in vacuum only we are discussing here speeds. Next is the light is deviated by the different amount, the angle between the incident direction and deviate final emergent ray. The angle is called as the deviations. Here different colors experience refractive indices because the wavelength is different. Therefore refractive index also different. Red light has the red light wavelength is lambda red is more than lambda blue, and therefore refractive index of the red is less than that of the blue. More refractive index for the blue, more refractive index means more deviation takes place. And for the problems will be given for you for the small angle prism, very important one. This one, small angle prism means the angle of prism is less than 10 degrees, 5 degrees, 2 degrees, like that they will take you. In such cases the Snell's law, sin I by sin R light, that form taken means sin I taken as a I only, sin R is taken as a R only. So here, and that means sin theta becomes equal to theta, tan theta also becomes equal to theta for the small angles less than 5 degrees. The deviation formula is equals to a into n minus 1. N is the refractive index of this material, and deviation of the ray is nothing but equal to a into n minus 1. A is angle of the prism. A is same for all the colors, but n is different for the different wavelengths. As the lambda changes, n also changes. N 1.5 glass, I told you, that is for the average of the 7 colors, that is related to yellowish green or yellow light depending on the color ranges you are given for you, given to you. So deviation for the small angle prism is a into n minus 1, and n is refractive of the material. If you take the red, d red equal to a same, n red minus 1. If you take the violet, d violet equal to a into n violet minus 1. If you take yellow, d yellow is equals to a into n yellow minus 1. Like that we have to take the deviations for the different colors, because the wavelength and n is not same. If the wavelength is the red is we said red is wavelength of the red color is very large compared to the blue. So blue refractive index is more refractive index, more deviation. So blue and violet deviate more compared to the red. Red deviates minimum, violet and blue deviates maximum. So blue I didn't write here. In the WIPGR you will get all the colors, so violet to red. In between colors I didn't write here. You will get WIPGR colors in this order. Red is on the top, violet is at the bottom case, because the difference in the variation in the deviations. Next we talk is the angular dispersions. For small angle prisms only, formula we are discussing here. Angular dispersions. Angular dispersion, but applicable, almost theory formula applicable for any prism angles, but problems will be given for the small angle prisms. Next is angular dispersion. Angular dispersion is nothing but the difference of the deviations of the any two colors given to you. That is called as the angular dispersion. They will mention the colors. If they don't mention the colors, they will say first color, second color, like that. They may not mention the names. If they give red and blue means delta blue, because the deviation of the blue is maximum. Sorry, this is violet given, blue is in between. Deviation of the blue is maximum compared to the red, so d blue minus d red. If the violet given means d violet minus d red. The substitution of these values, you will get the relation. Difference minus you take means this a minus 1 cancels. The result is a into nb minus nr. Refractive index of the differences into angle of the prism. And more refractive index differences, automatically more is the angular dispersion you will get. And the dispersion and deviation will be more if the difference in the refractive index of this glass and surrounding air is more. For example, if air is 1, glass is 1.5. If I take the prism kept in the water refractive index is 4/3, means 1.33. Now 1.5, 1.3 difference is less, so deviation will be reduced. For air I am taking here, so 1 and 1.5. So difference is more means more deviation and more dispersion also possible. Next is this depends on nature of the material. Refractive index is related to the only nature of the material. It also indicates the purity of the materials. Diamonds, pure or not, you can check up means you can go for the refractive index, which is 2.4 maximum, means that is a pure diamond. If not 2.4 means that is a fake diamonds. Next, angular dispersion, delta. Angular dispersion is nothing but equal to difference of the two deviations we discussed, and mean deviation, average deviation. Average or mean deviation is nothing but equal to sum of the values by number of the readings. That means blue and red, two colors only you are taking, so blue red, deviation of the blue plus deviation of red by 2, which is blue and red. If you are taking, that is supposed to be d yellow. Generally they don't give the blue and red, they may give the two colors, two wavelengths like that they will give. Then you have to take d1 plus d2 by 2, and here equal to a into n2 minus n1, and this will becomes equal to d mean only. But if you take the blue and red, the mean is nothing but equal to that of yellow light, deviation of the yellow light, d subscript y it is, not a d into y. Next, mean refractive index is nothing but equal to two colors you have taken, therefore blue and red by 2. This is suppose blue and red means mean refractive index is nothing but equal to yellow refractive index you will get. Next we discuss the term called as the dispersive power. Dispersive power is the ability of the prism to separate the colors, maximum separation. Now it depends on what factors. It is only mainly related to the refractive index of the material with respect to the particular wavelengths only. Angular, it is a ratio of the angular dispersion by mean deviations. These are all angular dispersion is the angle difference, so units are degrees only. Here also these refractive index don't know units and dimensions. Mean deviation is the angle only, so degrees. But a dispersive power is a ratio of the angular dispersion and mean deviation. Angular dispersion means difference of the two deviations by mean values. dB minus dr by d mean if you take the blue and red. Otherwise d2 minus d1 by d average. d1 plus d2 by 2 we have to take. dB minus dr by d yellow if for the blue and red you have taken. Substitute the values of this formula, you will get nb minus nr by ny minus 1. You need to know for the dispersive power. This formula for the numericals, and basic formula and this formula. Sometimes they will give the deviations, you have to use this formula. But mostly if they ask this from the refractive indices. Next is combination of the prisms. And one more thing is omega. This is not W, please. It is omega. It don't have units and dimensions. The ratio of the different distance, the ratio of the angles, therefore don't have units and dimensions. Next, combination of the prisms. If you take the two combinations of the prisms, then what happened to the color separation is there or not, and deviation is how much, that you have to take up on this. First prism, always prism bends the light rays towards its base. This is a base, towards the base. So if you take the two prisms kept reverse to one another, the first one deviates downwards, second one deviates upwards. Dispersion also can be taken by the first one and second metal. The metals are same. If the two metals are made of the same, if the two prisms are made of the same material, then just one prism is reversed to other prism. It acts like a parallel-sided glass slab. Then white light, if you passing, white light only comes out. There is no dispersion, no spreading of the colors, white light into different constituent colors. No dispersion takes place. If you take the two metals made of the same refractive indices, means same type of the material. But if different metals you have taken, means we take the refractive indices are different. N1 is different from N2. First one is deviating downwards and the second one deviating upwards. It is trying to go deviate upwards. So depending on the N1 and N2 values, we can cancel the deviation, means it will go parallel to the first case, means parallel sided glass slab, parallel to it. If the going separated from the initial direction, means that is a deviation is present. So for the parallel sided glass slab, we already discussed it before. If you have taken this light ray passing, white light, it splits, first one splits into colors, second one recombines colors and come out white as a white only if N1 is equals to N2. So in the glass slab or window glasses, the light is coming out without splitting into colors. Why? Because it is, you have to imagine this as a combination of two prisms. So first one disperses, the second one recombines the colors, coming back to the final emerging light will be of white light only. Actually what happens is when light is electromagnetic waves, they goes and oscillate the electrons here. Electrons absorb the energy, and again because the oscillates the electrons, they produce the energies, waves of the same wavelength, passes to next atom electrons, and finally they are sending into the air molecule. So light do not go just like that. It actually transmits form of electromagnetic energy, which is from electron to electrons of the atoms in the glass. If the glass is not transparent, means it will be dispersed in different directions, or electrons are absorbing the energy, not transferred to the second atoms. Also possibility if that is not transparent. Next is these different materials. Is the deviation, if you are to cancel, the first one deviation is downward, second deviation is upwards, means total deviation d1 plus d2 equal to 0, or d1 equal to minus of d2. Minus of may be mentioned here, or you can take d1 minus d2 also 0, sometimes they will be mentioned. Minus indicates the opposite direction of the angles. A1 is positive, means reverse kept, means second one is minus, it becomes. So a1 into n1 minus 1, because d1 equal to d2, first one d1 equal to d2, so a1 into n1 minus 1 is supposed to be equal to a2 into n2 minus 1, and this is a condition, please careful with that. Dispersion is there, but deviation is not there. Dispersion without a deviation you cancel it. So d1 equal to d2. So d1, if you substitute, no, you will get omega downwards. This is going to be delta. This is nothing but equal to delta by d mean or d average. D mean or d average we take. Delta by d means. So d mean is equal to constant, means what? Delta by omega 1 is equals to delta by omega constant, or omega by delta is constant. Omega 1 delta 1 is equals to omega 2 by delta 2. This condition you need to remember. This condition also you need to remember. Or even this also may be asked, please, rarely. Next condition is deviation without dispersion. Light is getting deviated, but dispersion not there, means so omega you have to cancel it out. Angular dispersion you need to cancel it out. That means you will get a delta 1 is equals to plus delta 2 is equals to 0. Dispersion is because of this separation of the colors. So delta 1 equal to delta 2, this part is same, means we will get omega 1 omega into d equal to constant. So omega 1 d1 is equals to omega 2 d2. If the two different metals given, generally use the term called as a crown glass and flint glass. Depending on the impurities added to the glass, that sodium metals as impurities added to, or calcium like metals added to the glass, that prisms have the different refractive index values. One is called as a crown glass, another is called as a flint glass. So crown and flint means automatically you must know that n1 is not equal to n2. So once again, deviation for small angles equal to a into n minus 1. Angular dispersion is nothing but equal to this formula. And this formula you have to note, dv minus dr, a into nb minus nr, average mean deviation, and mean deviation averages you can easily find out. Dispersion power, omega equal to nb minus nr by ny minus 1, or delta, angular dispersion by average values. And the combination of the prism if you have taken, if the same metals are given me, that is the same type of metals if you have taken me, that acts like a parallel sided glass slab. identical prisms, please. Identical. Non-identical prism means A1 is not equal to A2. N1 equal to N2, A1 equal to A2 means parallel sided glass slab. If A1 is not equal to A2, it is not a parallel sided glass slab. So refraction takes place in different ways. Next is dispersion without deviation. Means deviation you have to cancel. D1 plus D2 equal to 0, or D1 equal to minus of D2. It may be given as D1 minus D2 equal to 0, or D1 equal to D2. But minus sign indicates opposite direction for this. So minus sometimes is given as minus A2. Don't get confused with that. Negative sign, just leave it. Or other condition is omega 1 delta 1 equal to omega 2 by delta 2. Next condition is deviation without dispersion. Means dispersion you have to cancel. So delta 1 plus delta 2 equal to 0, or omega 1 d1 is equals to omega 2 d2. May be given as minus here, indicates one deviation is one side, other deviation is opposite direction, getting cancelled. And towards the red light, lambda increases, refractive index decreases. And towards violet, lambda decreases, frequency increases. And refractive index also increases. We need to work out the problems linked to this and some more points related to this dispersion. Rainbows. Just before the rain or after the rain, if the atmosphere is filled with water droplets, tiny water droplets, and sun, to observe this rainbow, the sun must be behind the observer, person is observing the rainbows, or called behind the observer. Sunlight going here in different directions, some light rays are going to the persons in front of the person, air molecules. Here some water droplets are there. In this water droplet, this is a white light we take. Water droplets refract the light here and falls here. But when it is light traveling from one medium to other medium, refraction takes place, but refraction is not taking place just as a single light ray. It is splitting into 7 colors because of the dispersion take place. So here you will get the 7 colors. These 7 colors again fall on the second surface. Here total internal reflection takes place at a particular angles. Light traveling from radar to water droplets easily goes radar to denser medium, but while traveling from denser radio medium, particular light rays, not all waves, many rays are going into the droplets, particular light rays which are going into a specific angle, they get a total internal reflection and reflects back to the person. All colors you will get. I am taking the 2 colors only here. These colors will be reaching to the person. Here also again take place deviation. Okay. The top color will be violet, bottom will be red. This is called as a primary rainbow. If the angle at this place, red, this is 40 degrees, this is 42 degrees. The angle, if expanded further, no, this is also around 40 degrees will be there, 40 angle to 42 in between, or Vibgyor colors will be seen here. And you will see the rainbow as a semicircular ones. Actually it is supposed to be seen as the circular ones. This semicircular one, and bottom is red, top is violet. For the prism, top is red, bottom is violet. Here actually they will go falling here, they cross the lights and then fall here. Red will be bottom, violet is on the top. This is called the primary rainbow. In between you find the Vibgyor colors. You are supposed to see the circular rainbow, not a semicircular rainbow, but because of the earth obstruction, we cannot see the complete rainbow. What you are seeing is, why it is supposed to be circular appearance is, when you are seeing from here, all the light rays make the same angle. So violet 40 degrees here, same possibility is there. Conical angle we can see that light rays. So we see this as a circular rainbow only. But part of the circle only we see. Where we see the complete rainbow is, complete circular rainbow where we see is from higher altitudes, from the aeroplanes or top of the hills. This rainbow need not be observed in the sky only, it can be observed in the near to the ground also, near the waterfalls. Some droplets fall, jump into the atmosphere. If the light source is backside, need not be sunlight, you can take the light bulb also, and in that case small droplets in the atmosphere, means you can see the rainbow, 7 colors. And complete rainbow is possible if you are observing from the sky, from the aeroplanes, from the balloons, or from the top of the hills. It is possible to see the complete circular rainbows. This is called as the primary rainbow. Primary rainbow refraction takes place, 2 refractions, 1 total interreflection, and dispersion takes place. Wherever the light traveling from one medium to another medium, dispersion automatically takes place. Just remember that one total interreflection takes place. But if the droplets are many, more height will be their atmosphere is more clear, it is possible that the light rays may go to the droplets which are at the higher, more altitudes, and they take 2 times reflection inside. This is the one reflection and second reflections. After this is white light. After falling into this, they will be splitting into the colors, and again taking the same colors inside. Here TIR, here also TIR, total interreflections. And colors will be reversed. Here top color, previously violet, red, now we would get is different colors. This will be violet, this will be red. This is called as the second rainbow. Second rainbow. The angles in only you need to remember primary rainbow angles 40 and 42 in between. Second rainbow angles for the light rays coming from the droplets makes 50 to 52 degrees approximately. 1 degrees we can make the variations between these two angles. You will get the second rainbow. Here 40-42 degrees angles, you will get the primary rainbow. Colors violet on the top, red at the bottom for the primary rainbow. This is called as a primary. And second rainbow, red on top, violet is red, but this will be less brighter than that of the primary rainbow. Primary rainbow is close to us, so light traveling through the atmosphere loses less energy, so more brighter. More brighter is primary and then secondary. 2 rainbows, one above the other we can see. So this is a primary rainbow, red, violet. Again with a gap you will see again one more rainbow, that is nothing but equal to violet and red. In between also possible to see the multiple rainbows also possible. They are called as a supernumerary rainbows, but visible only in the specific atmospheric conditions, not always. Angles you need to know, and how many total interreflection takes place for the primary rainbow, second rainbow, the numbers you need to remember. Next is atmospheric refractions and dispersions. In the atmosphere we have the air molecules, dust particles, water molecules suspended. Whenever the light is coming from the sun, which is supposed to be white light, has a different colors. White light we said, so different wavelengths are present. Red light if you have taken, it has a longer wavelengths. Violet light if you have taken, it has a smaller wavelengths. Depending on the intensity, the amplitude will be different. Okay. And this is a longer wavelength. These longer wavelengths can pass without touching the particles easily. So longer wavelengths can be traveled without hitting the particles of the atmosphere and can travel longer distances. That's why red light is preferred for the danger signals. Why red painting, red light is preferred? Because you can see that red markings, red light for the longer distance also we can see, because they hit with the air molecules less quantity, and if they hit, what happens? These high frequency waves are smaller wavelength waves. So this wavelength is larger, and here wavelength is smaller but frequency is more here for this. C equal to F lambda is constant. F is inversely proportional to lambda. More lambda, less frequency. Red light has a longer wavelength. This is 1 wavelength lambda. This is a 1 wavelength lambda. So these particles are more probability of hitting with the atmosphere. These waves have the more probability of hitting the particles in the atmosphere. So what happens when they hit? When they hit, they diffract in the different direction. After hitting here, they may go in different directions. Depending on the size of the particles, the reflection will be different direction possible, and roughness also important. Reflection of the light in the multiple direction is called as a scattering. Scattering of the light is nothing but reflection only of light in the multiple directions is called as a scattering. Just like the one ball, if you take one ball, you are hitting on the ground, it falls and jumps. If you take the multiple balls and drop it, there are multiple directions they will go, many drops. They are nothing but scattered in different directions we say. Not only that, if the smooth surface is there, if you are dropping the ball like this, it will go like this particular direction. 2 balls to take also same particular direction only, they are reflected. You can apply the laws of reflection here. But if the surface is not smooth, rough surface is there, then one ball is falling here, reflect in one direction, another ball falling here, reflect in the other directions, multiple different directions. This is called as a scattering. Reflection in the multiple direction is called as scattering. Laws of reflection applicable only for the particular waves and the particular position only. So if you take the transparent glass plate, light easily passes through it. But if the grounded glass plate means rough surface, if you take light is not passing through it, is because light roughness is there. So light falling on it reflects in the multiple directions, waves. They are not passing through it. They pass also, less quantity will pass. So it's not clearly visible outside objects. So what happens here is the light waves passing through this will be scattered by the different directions, but red light and violet to red if you have taken violet and blue scatter more than that of the red. So red waves can travel easily, more easily, but some scattering takes place but less quantity. So blue and violet scatters more, which is maximum scattered is violet is scattered more. So what happens is that it spreads in the different directions. Spreading in different directions, the sky appears blue. Because of that, violet scatters maximum, but violet and blue mixed up, indigo mixed up means our eye is sensitive towards blue, so we say blue sky, we never say violet sky, because the violet scatters more, but next scattered is indigo and blue, mixing is bluish only we say. And red is scattered minimum and can pass through the atmosphere over the longer distances. So the intensity of the scattering is given by the scientist called as Rayleigh scattering formula. Is intensity of scattering formula is lambda to the power of 4. 1 by reciprocal of lambda to the power of 4. More lambda, less intensity. So if you take the frequency terms, no, C equal to F lambda, therefore intensity is proportional to F to the power of 4, because C equal to F lambda is constant. They will give you which intensity, which light is more scattered means lambda red is greater than that of the lambda blue. So blue is scattered more than that of the less lambda, more intensity. Lambda fourth power, it is called the fourth power of the wavelength. So blue color scatters more than that of the red. Through the fog also we can see the red light, but not other colors lights easily. Even aeroplane is flying at higher altitudes, it has a different color bulbs, but you will see the red light easily, because the red light travels over longer distances without getting scattered or losing the energies. Even the sun, sunrise, sunset, sunrise, sunset, this is the earth, this is the atmosphere. If you are standing here at this point, this is called as a horizon within this level, where the sky appears to touch the ground for us. So when you are seeing from here, the sun is up to this, you directly can see it. When the sun is straight above our heads, the light travels over the longer distances, smaller distances. Because of the reason, you will find lesser scattering. So you will find sun as white, not actually white, it is supposed to be yellowish colors, because the 7 colors are averages nothing but equal to yellowish approximately, light yellow colors you will see here. But small scattering takes place, but less amount scattering. The intensity is maximum here. Intensity of light is also maximum because light travels over the smaller distance. But when you are traveling from the sideways, it has to travel the more longer distances in the atmosphere. So scattering takes place. So intensity of light decreases the morning. This is the evenings. So I am taking that rotation of the earth conditions. So when morning means sunrise appears to be increasing like this and goes like this. The noon time. This is the evening time. So noon time the intensity is maximum. And evening, morning intensity is less because of the light scatters more. But what happens after the sunset takes place? Horizon, crosses the horizon, still you will see the sun. When it crosses the horizon, you cannot see here light actually directly, but still it is visible because light goes, refraction takes place, traveling from the vacuum to air. N air is greater than that of the N vacuum. N vacuum is nothing but equal to 1. N air is 1.30 something extra, you will get some greater than 1. You have to take N air. Sorry, N vacuum is only 1. N air is not 1. So what happens here is light traveling from red denser medium deviates towards the denser medium. So it bends like this. So even though it is not in the horizon, still you can see it. But this, because the scattering over long distance is traveling through the atmosphere, that reason it appears to be red light. Next, red or orange red colors you will see, and also because the light traveling here, no, it spreads over large areas, so you will see the bigger image. Same thing happens even in the evening also. After sunset also still you will see the sun. The red sun you are seeing is not real sun, please, it is already went. What you are seeing is the virtual image of that. Means light appears to be coming from here, illusion. Sun is not actually there, you are seeing its light is after deviation. So we imagine sun present here, it is not real one, that is actually virtual ones. And 2 minutes difference you will get here, morning and evening. The sun is still visible, 2 minutes extra in the morning, 2 minutes extra in the evening. 4 minutes of the daytime you will see from morning to evening, sunset to sunrise cases. And sun appears bigger because of the scattering of the light spreading, like torchlight spreads the light in atmosphere over large areas. Only laser light spreads minimum, but that is monochromatic wavelength, high intensity. Laser spreads less. It do spread, but less. But this ordinary light spreads more, and because of that reason, sun appears bigger. Not only that, because the angle here taking place more different from the top to bottom, angle of incidence and emergence different. Therefore, it is not perfectly spherical. It appears a little oval shape. Top end will be little pressed down, appears to be slightly pressed down, because of this angle changing from bottom rays to top rays of the sun entering into the atmosphere. Okay, we'll stop here now. Next few problems are there related to this dispersion. We'll discuss that problems in the next class.